You ever just stare at your screen and wonder about the actual magic that's happening behind the glass? Well, today, we're going to pull back the curtain on the secret software that paints every single pixel you see. We're talking about the unsung heroes of your digital world, display drivers.
No, really, think about it for a second. How does a single command to draw, say, a dragon, travel from a line of code all the way through your computer and onto your screen as this gorgeous, fluid image? The answer is way more fascinating than you might think.
And here it is. This is the hero of our story. A display driver is basically a master translator. It takes these generic requests from your software and turns them into a very specific language that only your graphics card, your GPU, can understand. Without it, all that powerful hardware would just be a very expensive paperweight.
So here's the game plan for today. We're going to start with the ghost in the machine. Then we'll uncover its kind of split personality. After that, we'll follow a single command on its grand tour, see how it all goes from code to pixels, and finally, we'll get into the immense power and, the risks that these drivers hold.
All right, let's dive in. The best way to think of a driver is like an essential diplomat. It stands right in the middle, between the world of your software, your games and your apps, and the physical world of your hardware. Its whole job is just to make sure those two can have a productive conversation.
Now, here's where it gets interesting. The driver isn't just one single program. It's actually more like a team, an architecture that's split into two totally distinct parts, and each one has a very specific job. You've got the user mode driver and the kernel mode driver.
And this separation is everything. Okay, so first up, you've got the user mode driver, or UMD. This guy lives in a safe, sandboxed space right alongside your apps. Its main job is to do all the translation work. Then you have the kernel mode driver, or KMD. This one runs deep in the heart of your operating system. It's got privileged access, and it's the one that directly commands the hardware. This split is absolutely critical for keeping your system stable, as we're about to see.
So how do these two actually work together? Well, let's follow a single graphics command on its journey. We're going to trace its path from an application all the way down to the pixels lighting up on your screen.
Okay, let's break this down. It all kicks off when your game sends a request through something called a graphics API. Think of that as just a set of rules for asking for graphics. The operating system then hands that request off to our friend, the user mode driver. The UMD does its main job, translating that generic request into a specific list of commands the hardware can understand. That list then gets sent down to the powerful kernel mode driver. The KMD schedules the job and basically tells the GPU, all right, get to work. It's a very strict, one-way street from software down to hardware.
So, to put it all together, it's just like this perfectly coordinated assembly line. The application makes a wish, the API sets the rules, the OS acts as security guard, the UMD translates, the KMD commands, and finally, the GPU does all the heavy lifting.
Okay, so that's the how, but why should you actually care about any of this technical stuff? Well, it turns out the quality of this invisible little piece of software has a massive direct impact on your everyday computer experience.
I mean, a well-written driver means everything. Higher frame rates in your games, smoother video playback, you name it. And remember that user mode/kernel mode split we talked about? That's what stops one buggy app from taking down your entire computer. Good drivers also unlock new hardware features and make sure all the latest software actually runs the way it's supposed to.
It really all boils down to this. The quality of that driver code, the stuff written by engineers at companies like NVIDIA or Intel, is directly tied to how smooth, how fast, and how stable your computer feels every single day. And this is exactly why you're always told to update your drivers. Every single update is a chance for the manufacturers to fix bugs, squeeze out a little more performance, and add support for the latest games and apps. It's not just a friendly suggestion, it's pretty much essential maintenance. But with this kind of power comes some pretty significant risk. I mean, when you give a piece of software such deep, privileged access to your system's core, things can go very, very wrong. This right here is why that UMD/KMD split is so brilliant. If the user mode driver crashes, okay, your game closes. It's annoying for sure, but your computer is fine. But if the kernel mode driver, the one with all the power, if that crashes, your entire system goes down. We're talking blue screen of death. You need a full system restart. The difference isn't just annoying versus inconvenient, it's annoying versus catastrophic. And the risks really don't stop there. Because the KMD has such deep access, a single security flaw could literally give an attacker complete control of your system. Plus, drivers use up precious CPU power. And here's a big one. Manufacturers eventually just stop updating them for older hardware, leaving those devices vulnerable and unable to run the later software.
So that leaves us with this final question, right? Is your display driver a silent partner that boosts performance, or is it a hidden risk buried deep in your system? The truth is, it's both. It's the essential key that unlocks your hardware's true potential, but at the same time, it's a deeply embedded risk that requires our trust and constant maintenance. That unsung hero we met at the beginning, yeah, it has a dark side.